Hello everyone, and welcome to our webinar 26.1 release introduction and beyond Java, Linux apps in the Webswing. My name is Martin, and I'll be your host today. I can already see many familiar names in the audience, which is always great to see, and also many new names, which makes me even more excited for today's presentation. So thank you all for joining us. Today we have prepared a session that combines two things. First, a look at the new features in Webswing 26.1, and second, a very, very interesting preview of where the Webswing is heading next, especially beyond Java, traditional Java desktop applications. So we will not only talk about improvements and new capabilities, but also show you some technology that we believe opens a very, very exciting direction for Webswing today. I will not be presenting everything alone today. I'm joined by two of my colleagues who know these topics much more deeply than I do. Can I have a next slide, please? Perfect. First, we have Andrej, who is responsible for operations and software development. Andrej will walk you through the first part of the webinar. And then we have Robert, our senior developer, and Robert will take you over the second part of the webinar and introduce the topic of Linux desktop application in a browser. My role today is to guide you through the session, keep the ball moving, and then I'll come back at the end for the Q&A. So let's quickly look at today's agenda. First, we will start with the new features in Webswing 26.1 and what updates we have prepared for this new version. And after that, we will move into the second part, and that's how to run, or that we call Beyond Java, and that's how to run the Linux applications in the Webswing. This is where we will introduce our technological preview, the idea of bringing Linux applications into the browser. Robert will deeply explain the architecture, the reasoning behind it, the advantages of the technology, and also where we see the practical use cases in the future. Then we will move into the demo, where we will see it in action. And after the demo, we will also speak briefly about what comes next in a foreseeable future and what you can expect us to deliver in upcoming months. At the end, we will open the floor for Q&A, so please feel free to write your questions during the session. We'll collect them all and answer them at the end. So with that said, let's begin. And now I would like to hand it over to Andrej, so we can start with the Webswing 26.1 release. So Andrej.
Thank you, Martin. Hello, my name is Andrej. I will briefly talk about the new features in 26.1. Here as mentioned, next slide, please. So we have added, in compliance with our release plan, support for new LTS version of Java. So for teams who want to stay on the latest features of Java, can use 26.1 for this, and Java 25 is fully supported. Yep. Next slide, please. We have introduced also a new session mode. It's named Choose Session for User. It's a combination of continue a session and ability to start a new session. So for users who are multitasking and needs to have several instances of the same application opened at the same time, during the startup period, if there is already a session for this user running, pop-up as shown on the slide is presented to the user, and user can select existing session or can start a new session. So yep, this is fulfilling some use cases for some users. Next slide, please. Improved handling of inactive browser tabs. So recently, Chromium-based browsers introduced a new energy saver mode in which they try to optimize energy consumption of mobile devices and basically maximize the battery life. In this mode, the CPU is throttled, and under some conditions also the JavaScript execution is halted. And in the past, basically Webswing swing session was still sending the messages over the WebSocket because the WebSocket can stay open, and the session basically sent it the messages, and it caused for accumulation of these rendering messages to build up on the browser side. And once the user returned to this inactive tab, all these messages had to be processed at the same time, and sometimes it caused issues with certain applications which were basically rendering in the background still something. So it was causing some downgrade in user experience, and in specific cases also issues which are now solved in this new handling. So basically Webswing detects this and also handles the communication in a way that this does not downgrade the user experience. We are still continuing our work on Oracle Forms, so we had support for Oracle 14, 12, and now we have added Oracle 11, Oracle Forms 11. So whoever is needing this Oracle Forms 11, they can basically jump directly into this, and it's working as usually. Also, we have added some support for file handling, PDF, the printing functionality, and this is still ongoing as we are having some new customers using this. We are basically improving according to actual requirements. Next slide, please. Similar to Oracle Forms, the SWT, so we have added some features that were either missing or like barely used. Then there was a new feature for data binding for database-backed use cases, and we have also created one big SWT demo, which basically shows all these components supported within our Webswing integration with SWT. So this is also ongoing task as new applications are coming and new features are being added. WebSocket stability improvement is basically in cooperation with one of our customers. We have simulated some very special edge cases, and we also observed in big deployments, in cluster deployments with many users, as special conditions that can happen with WebSockets, mainly during the opening when there is a handshake happening and one of the part or one of the components fails in this process during the handshake. The WebSocket connection can be in faulty states. So we have identified these states, and we have improved the algorithms and the logic behind establishing WebSocket connections, and also behind finding a stale WebSocket connections where either one side drops the connections, or there can be also a network proxy which basically drops the WebSocket connections, but the clients on either side can still consider the WebSocket connection open. So this has been improved, and now the WebSocket connections are more reliable than before. The new lifecycle REST endpoints have been added mainly for Kubernetes deployment, where basically when you basically need to be sure that the container is up and running and can serve, or when the container is down and cannot serve the connections. This is all required for this Kubernetes management and therefore it has been added per customer requirements. I will also mention some other enhancement. The admin console, there were some small GUI issues with some certain either large number of sessions or different screen resolution. So we have improved this, and we have also added some other minor fixes that basically those who use admin console will notice it. Then in security modules, all three major security modules, either LDAP, OIDC, or SAML2, has been improved with some rarely used features, but as they were requested by our customers, we have added them, and now all of you can basically take them and use them as if required. I think this is all regarding the new features in 26.1. Next slide, please. Yeah, now I will give word to Robert, who will talk about the Linux desktop to web.
Yeah, hello everyone, welcome. Let me introduce the new product that we've been working on and allows us to bring Linux desktop applications to web. So we came across a challenge that many companies and many customers are using enterprise applications that often extend beyond Java, whether it's to other programming languages or various frameworks, graphics toolkits, or even operating systems. And as you may already know, legacy desktop applications tend to be difficult to replace or modernize, whether it comes to either financial or time constraints. So it's not really feasible for each company to sort of modernize their application portfolio into web applications. And with that being said, they often have to use separate solutions, since, as you may know, solutions for running desktop applications in a web browser are often tied to the specific technology, let's say, for example, Java. And once you have separate solutions for each application, it often adds operational complexity in the form of licensing and support. It also limits the ability of application cooperation, so these applications cannot launch each other or exchange information. So we came up with an objective to bring Linux desktop applications to the browser, and the solution that allows us to do so is the Linux Web Launcher, which is basically a custom Wayland compositor. And you may be asking, what even is a Wayland compositor? So it's a modern Linux display server, which is present in basically all operating systems that are running on a Linux core. And the main role of display server is to manage client connections. Each client is an application, and the display server needs to make sure that application is able to connect to it. Once the application is connected, it will commit surface updates and notify the compositor or the display server of the updates that need to be performed. Once the compositor receives these updates, it will manage the surfaces, which are basically just application windows, and compose a final scene out of them, so the output can be presented to the user. And once we have the output, we also gonna need the input. So the display server is also responsible for routing input events to the application. It also provides isolation to some extent, where it makes sure that applications cannot interfere with the rendering of each other, and they neither can steal input events from each other. And you may be thinking that the Wayland compositor may not be enough to achieve our goal, and you would be right. So there's also the Linux application that just runs on the server as it would on any other Linux machine. And then we have the custom Wayland compositor and the middleware that we have created. So the compositor provides the display environment for the application, And it also composes windows and renders the output to a buffer, from where the middleware picks up and captures the frame and hands it over to the existing Webswing infrastructure, which makes sure that the output is being delivered to the browser session of the user. So to get a better view of how this all works and how it's all wired up, we can take a look at this diagram. So we can notice the custom Wayland compositor here in the middle. It talks to Wayland client or X11 client through the X-Wayland. X-Wayland is basically a compatibility layer for X Windows system, so we can also run older applications. And you can also notice that both X-Wayland and Wayland clients are capable of direct rendering through open source user-mode graphics drivers such as OpenGL or EGL into the graphics memory, from where it's captured by the capture middleware and handed over to the existing Webswing infrastructure. To get a closer look at the frame lifecycle, we have this diagram here. The lifecycle consists of three main stages. First, we've got the composition, the transport, and the presentation. So starting with the composition, we have the Linux application that can either be a Wayland or X-Wayland client. It connects to the display server and handles its own internal graphics updates, which are then being committed to the compositor. Once the compositor receives those updates, it will update the scene graph and the output state, and it will render the output frame to a buffer, from where it will be captured by the capture middleware, and the frame emitter will be further notified. The frame emitter queues those frames and removes any duplicates, so we are saving the network load as well as the hardware load. And then it encodes those frames on demand, so only when they are needed, yet again, to save on the hardware resources and network load. And once the frame is being encoded, it's then being sort of transformed into a render update message. With that, we are entering the transport stage of the lifecycle. So the render update message is being passed to the connection manager, which is responsible for ensuring a stable connection to the Webswing server. It also encodes the render update message and sends the message over WebSocket to the Webswing server and makes sure that the message is actually being delivered to the server. And once the message reaches the server will deserialize and decode the received message, and it will split the data into server and user data. The server data will be processed directly on the server, and the user data will be further routed into the session router. In the session router, the target user session is identified, and the data is being forwarded to the target user session. So with that, we are entering the presentation stage of the lifecycle, where the data is received at the browser WebSocket connection, and the dispatcher takes care of decoding the payload of the user message and validates the message data integrity. So we make sure that the message was not modified in the transport stage, and it contains everything we need it to contain to perform the render update. The dispatcher then generates update instructions and dispatches them directly into the render pipeline. The render pipeline then batches those instructions and yet again removes any duplicates and queues actual paint requests. And these paint requests are then being processed by the renderer, which actually executes draw operations and performs browser-side surface composition. So it acts sort of like the browser-side compositor. Then it's just a matter of updating the HTML and DOM at the web UI and waiting for either further updates from the compositor or user input events. So yet again, as a recap, we've got the composition, transport, and presentation, and starting with the application that produces commits, and the compositor will process those commits, bundle all those updates, send them over the WebSocket to the server, from where it is being forwarded to the browse a session where the user can see the output. So now that we know how this works, you may also be asking why we chose the display server level and why exactly Wayland Compositor. So when it comes to the display server level, it's actually the one and only common layer for all desktop applications. All desktop applications have to go through this layer. It's something that's being present on all operating systems, and no matter the application graphics or application technological stack, the application will be rendered by this technology. So yeah, this is the reason that allows us to capture all applications. And the similar way, since this is such low-level application or solution, we are able to capture real application output. So we are sort of mirroring the application behavior that it would have on a regular Linux machine. And the last reason that we have decided to go with display server level is that it supports headless execution. So even though we are leveraging desktop environment features, the solution itself doesn't have to be on a machine that has a desktop environment. So we are reducing the overhead that this solution could have had. And yeah, so once we agreed on the display server level, we had to choose between Wayland and X Windows system, as these are the two main display servers on Linux. So Wayland being the modern Linux display server architecture and sort of the successor of X Windows system, it was sort of natural to go with this one. And Wayland also supports X11 applications through the X-Wayland compatibility layer. So it's backward compatible, which cannot be said about X Windows system that cannot run Wayland applications. So let's move to the advantages and trade-offs. And yeah, when it comes to advantages, the main one, as you are already used to in Webswing for Java, you don't have to update the application, you don't have to perform any application rewrites. The legacy desktop application just will work out of the box as is in our solution as well. And yeah, the next advantage is that we are not using any toolkit specific integrations. So no matter the technologies your app is using, it will be compatible with our solution. We are also preserving the native application appearance. As already mentioned, we are trying to mirror the behavior of the application that it would have on any other Linux machine. And last but not least, we are keeping applications in their original runtime environment, so we are not limiting them when it comes to their capabilities or features. We also have some trade-offs, or want to be specific. So when it comes to capturing and rendering the application output, we have to do it at the pixel level. So this results in not having any semantic UI components in the browser, so you will not find any HTML tables or buttons or links in the HTML. It will all be just images. While this could be a trade-off in some niche use cases, it's also the same thing that allows us to preserve the native application appearance, since we don't have to recreate UI components. And with advantages and trade-offs being clear, we can move on to common use cases. And we believe that both existing and new customers can leverage this solution and benefit from it. So when it comes to existing customers, the most common use case is launching either helper system applications or specialty non-Java applications, such as file editors or viewers. The most common use case actually is that many customers need to launch a command line or terminal session from their Java application. And right now they need to integrate this terminal or command line session into their Java application, which is not necessary anymore thanks to our new solution that allows you to just launch another application that's not Java. When it comes to new customers, They can mainly benefit from our solution by getting their entire application portfolio integrated into Webswing and leverage their mixed Java plus Linux workflows or cross-technology workflows. Let's say you have a Java application and a Python application built for Linux. You can now run these applications in a single system, and they can cooperate with each other and exchange data. And another good use case is managed access to shared application instances. So let's say you have a shared application, single instance running on a remote machine, and many users are connecting to it. So before you would need to use RDP, which sort of limits the usability of it because users could interfere with each other and block each other. It also exposes a security risk where you cannot really tell which user performed what changes. But thanks to our new solution, you can just run multiple instances of the same application on a single machine without having to sort of like clone the entire desktop environment. So it basically reduces the overhead that you would need to have before. And yeah, so while this may sound a bit abstract, we can move to the demo. So we can maybe show it on a specific example. But first, we're going to take a look at the admin console and the newly added Linux application configuration fields to show how easy it is to set up a Linux application in Webswing or the Linux web launcher. And then we're going to move to the application showcase. We're going to take a look at the sample cross-technology workflow with file handoff. And the main highlights to look for is the virtual printing, file access processing and isolation, and the cross-technology file exchange and application launch. So as for the first part of our demo, this presentation was actually running in a Firefox that was running inside of a Chromium thanks to our solution. And as you could see, the presentation was running perfectly fine. You could see the output and we could switch those slides. And you can also see that the browser itself is also perfectly fine. So with that being said, we can move to the next part of our demo and take a look at the admin console. So going to the applications, we can choose a Linux application and take a look at the application config. So some of you may notice that we have moved the launch type from the bottom up to the top, and we have added a new option, Linux, which once selected will present the Linux web launcher section, where you really just need to focus on three fields: the application backend preference, which you can either set to auto or prefer-valent or prefer-x-valent. Then there is the application executable, which is the path to the binary that you would use to launch the application, and application environment, which sort of is used to pass environment variables to the application. Yeah. So now we can proceed to the application showcase. And we're going to take a look at these two applications, the Tire Machine Console and Tire Config Manager. These are sort of just demo applications. The Tire Machine Console is a Python application built for Linux that's sort of acting as a console for monitoring and managing a tire manufacturing machine. And then there is the Tire Config Manager. That's a Java application, and you can use this to update the configuration of the Tire Machine Console. So opening the application, we can see that there are a lot of data, and it's running with some warnings. So when we take a closer look at it, we can see that the extruder temperature recovery is being too slow. And looking at the config, we can notice that extruder heat to power is set to 40%, which already sounds a bit low. So let's proceed to the configuration manager, where we can fix this issue. And we can indeed see that the specific line with 40% power is highlighted, and it says that the heat to power limit is below the recommended range. So we can fix this two ways. We can either just type the value here and hit enter and then apply config, or we can open an existing config that contains the proper value. So let's do that. And now we could either save the config and open it in the other application, or we can hit the apply config button here. And now we can see that the Java application has launched a Linux application and passed a file in the background. And we can also notice that the Linux application has picked up the file and noticed it. And it prompts us to apply the configuration. So we can see that now it is set to 40 as it was before, but we can apply the config and it will update to 90. So that means that the file handoff in the background was successfully processed. The other way of doing this is opening a file. So we have also included the file processing feature in Linux applications as you are used to it from Java applications. We are now using the isolated file system with non-transparent file UI. So let's select maybe this file, and upon opening it, we can see it did change the value. So let's put the correct one back. And this one, yeah, so it's fixed again. And maybe to verify that we have indeed fixed the issue, you would want to view some sensor data. So let's take a look at that. We can hit this button, open sensor data in a file. And now we are launching a Linux application from another Linux application, and yet again passing a file in the background. We can see that now the file is quite a bit bigger as it contains many values, and the file handoff was successful. We can maybe insert a chart to get a better view of this data. So let's insert chart, line chart. And yeah, we can move the chart around perfectly fine. We can move the entire window around. And maybe you would want to sort of archive that you have resolved the issue. So we can hit Control P. And as on any other machine, we are presented with a print dialog that contains the print preview with all the data and the chart. And we have the Webswing virtual printer pre-selected. The printing is also possible on a physical printer, but for the sake of the demo, I think it would be for the best to use the virtual one. So let's print on that. And we could see a brief loading in there, and the PDF file has opened in a new tab. And it indeed contains all the data that we have been promised in the print preview. So that's it as far as the demo goes. You can go back to the presentation, switch to full screen. Yeah, so you could see the admin console and the newly added Linux-specific configuration fields, and the application showcase with virtual printing, file access, processing, and isolation, and the cross-technology file exchange and application launch. So as you can see, most of the features are implemented and applications are running fine. So the next focus of ours will be the deployment readiness of this solution, and mainly the stability and the performance of it. And you may also be asking, what about Windows applications, since the enterprise environment is more Windows focused? So those are already supported via Wine. We are fully aware that Wine may not be for every use case, every user, and every application. So we are already working on a native support of Windows applications as well. And this solution is under development. So we will be keeping you updated on that in the upcoming months. And when it comes to the availability of this solution, you can either get your hands on the early access, which is sort of on demand. So if you are interested, don't hesitate and contact us at sales@webswing.org, or you can just wait for the public release, which will be coming out in the version 26.2, which should be in the October 2026. So with that being said, I'm now handing it over to Martin.
Perfect. Thank you. It was a lovely presentation. For a little while, or rather say for one slide, I would like to give the word back to Andrej to sum up what's next for Webswing in an upcoming release. Then we'll move forward.
Yeah, so I will go through this. So for the next release, the first point is what Robert just showed us. Thank you, Robert. Then we are working on a wizard style helper for configuring the production environment. We want to make an example that will improve and speed up the deployment to production, because we have found out that one thing is bringing application in Webswing up and running, another thing is running it in production. So therefore we have decided to bring this helper feature with clustering, auto scaling, authentication. Everything should be easier to configure and guide it automatically. Then we are working also on admin console optimizations, mainly in cluster deployment, where the large deployments basically bring some challenges in the synchronization of the configuration between all the nodes and all the components. So this is under development. Then on-demand examples is we are basically trimming the distribution. As you know it right now, we have two distributions. One is standard, another is standard with examples. We want to bring these examples also to the standard distribution, but you will be able to download them when required. So you don't need to download everything. You will just download what you want and what you want to see. Then also improvements for JavaFX, which is currently is specially handled, and we found a way for improvement here for the direct draw and the JavaFX. Then also SWT, that's a long-term improvement, because there are many versions and we need to still support all the new versions that are released frequently. Last but not least, quite important, is improved support for Q&A and testing. We have added in last version support for JMeter, but now we also want to extend it further for better testing, and also add some for the Cypress plugin. So if you are serious about Q&A and testing, then the next version will provide more features for this. Okay, I will give word back to Martin for the questions.
Beautiful, beautiful. Thank you very much, Andrej, Robert, for walking us through this new technology preview and release updates. It's honestly really awesome to see the progress in every single release version of Webswing. It's really incredible that our development team keeps coming with the new and useful features and products for our clients all over the world for more than a decade now. So we hope you liked this presentation, and we are convinced that you very soon will find the usage of these new features in Webswing. And now, as we have reached the Q&A part of the webinar, this part will be cut out from the video sharing on social media, so we can make it super unique for you, for those who are being presented.